Again, this is section 1.5, part 1, and we're talking about analyzing the graphs of functions. That's just for the sake of the video. I know you guys already got that. So what we're saying is the graph of a function f, it's a collection of ordered pairs, x, y's, right? In this, you'll notice it's called x, f of x, but remember, we can always just turn f of x into y, such that x is the domain. That means, as we talked about before, when we're talking about domains, your input value is your domain. Anything that x can be is your domain of f. And as you study this section, remember that x, the directed distance from the y-axis. That just means your x goes this way, left to right, and y equals f of x, which is the directed distance from the x-axis, right? And that just means your y goes up and down. It's saying that y is, like here, it would be about 1 1/4 away from the x-axis, so it's 1 1/4. This point right here is 1 1/2 away from the y-axis. That's what they mean by directed distance from the y-axis. So forget the more complex in definitions. You know what x and y are. X is whatever goes from left to right. Y is the up and down. When we're talking about the domain and range of a function, we talked about this a little, and we're going to go through it here. I'm going to turn my pen on really quick and do a little writing in blue. So here it's talking about the domain of f. That means we're talking about the domain of f, which is this graph right here to the right. Right? That's the direction. This one, right? I can't do that. Try to make my pen actually write as a pen. Let's see if we can get this working today. There we go. We're talking about the graph here, right? For this one. And it's saying the domain of f. And the domain can be absolutely anything that our x can be. But if you notice in this section, our x ranges from -1, right, with a closed circle. So our domain is going to be bracket -1. That closed circle, if you guys remember, means that we're actually including that number, right? And it goes all the way to 5. So I'm going to put 5 in here, but then we're just going to put a parentheses. We can't put a closed bracket because it doesn't actually include 5. And if you remember, that open circle means that number is not included. It'll go all the way up to 5, but it doesn't actually include 5. So that's how we would show the domain of f, right? It runs from -1 and includes -1, and it goes all the way up to 5, but does not include 5. When we're talking about B, it says the function values of f at -1 and f at 2. You could read that as f of -1 or f of 2. Does anyone know what it means by the function values, f -1 and f 2? It's a lot simpler than you might even imagine. It just means that you plug those numbers in to the equation at -1 or 2 if you're dealing with an equation. But here at f of -1, all we have to do is go to, well, x equals -1. We're plugging it in for x. So we're saying, what is our y when x is -1? And in this case, it's just 1. Let me see if I can Do you see that? It's this point right here at x equals -1. So our f at -1 equals 1, right? It's that y value when x is -1. What is f at 2? When x is 2, what is y? You are close on that one, Avery, but look where that 3 is. Is it above or is it below that axis? Or did you actually say -3? Yeah, it would be -3. Can you see that? Here where x is 2, right? Y is just -3. So if you're looking at the value from a graph, you can always tell. Just go to whatever x it's asking for and tell me what the y is at that point. The range is all of your potential y values, right? Your lowest y value all the way up to your highest y value. So C is asking you for the range of f, right? And so the range of f is going to go from our lowest point, which it includes, is -3, all the way to our highest point, which is +3. It includes both of them. And how can I tell it includes both of them? Because I'm super smart. But not really. That's not why. I can tell that it includes both of them because at each point we have a solid dot, right? So we know those values are included in the range. So domain is your x's, right? X values. And the range is your y values, right? Anything they can be. So if we're looking at this checkpoint that I put in here, tell me what the domain of f is on this graph. What is the domain of f? One thing I would like you to think of on this is that these go on forever. What are your potential x values? Let me see who's here. I'll just call on people. Ryan, what is the domain of f? What are your possible x values? Are you there, Ryan? That is a good guess. That is a good guess. In this case, though, because of the arrows, I can see why you would think that because that's where our graph ends. But because of the arrows, because it's a function that goes on forever and ever, it's actually all real numbers, right? We could take it from -infinity to +infinity. It's really hard to make infinity symbols in this direction. Does that make some sense? As to why? Because x, we're not limited by anything x can be. Now, for the purpose of what we see in this graph, it technically goes from -3 to +3. But because this graph technically goes on forever and ever, it would be Yeah, all real numbers means it will go from negative infinity all the way to positive infinity. What are the function values at f of 0? Alex. So f of 0 means when x is 0, what is y? Right? So Alex, when x is 0, what is y? Caitlin, you want to help him out? Okay, Alex, thank you for letting me know. Where is x 0? Yes, it would be 3. Think about this. Here, x is 0, right? This is pre-calculus. You guys should be able to do this one. X is 0 anywhere on the y-axis, right? Because we're not moving away from the y-axis where x gets bigger than 0, right? It's our y-intercepts. When x is 0, look, there's even a point right here that says, my stuff keeps moving, right? X is 0. Well, what's y when x is 0? It's 3. Let's try this again with f of 3. Caitlin, I'm going back to you. When x is 3, that's what this says. F of 3 says when x is 3, what is y? I'll give you a hint. There's only 3 points listed on this entire graph. When is x 3? Yes, perfect. It's negative 6. Now we can look at it. We can see it right here. X 3, the point is at negative 6, but it's actually listed, right? Like I said, there's only 3 points on this entire graph. The range of f is what are all the values that y can be, right? X, domain is our x values, the range is our y values. Now, our domain could be all real numbers. We've already discussed that, right? But our range has some numbers that aren't included. Because if we notice right here, our y values don't go up above here, right? They go down forever and ever for infinity on both sides, right? But they don't ever go above 3. They include 3, but they don't go above it. So when we're writing our range, we are going to say, because we go lowest to highest, negative infinity, because it'll go all the way to negative infinity, to 3, and the 3 will be in a bracket. This stuff's starting to come back to you a little bit, seeing it? A little bit? What slide am I on? The next thing we're going to talk about is zeros of a function. Now, we have this nice little mathematical explanation of what the zeros of a function are. Y equals f of x, which means that we can interchange f of x and y. Are the x values for which f of x equals 0. Well, f of x, if we look at this, are just the names of these functions, of these equations. So they're saying if we set this equation equal to 0, we're going to find the zeros. And you guys have done this. You've been doing it for a long time. You just might not have called it that. So we're going to solve A, B, and C. And we're going to look at this and we're going to go, well, A is f of x equals 3x squared plus x minus 10. And to start solving that, to find the zeros, all we have to do is take 3x squared plus x minus 10 and set it equal to 0 and then solve. Now, do you guys remember what we would use to solve an equation like this? I mean, it's the one that's tattooed in my brain. It looks a little like x equals minus b plus or minus the square root of b squared minus quadratic formula. Thing is like ingrained in me. I'm going to get a tattoo one of these days, I swear, of the quadratic formula. Not really. I wouldn't do that. I mean, I might do that. Who knows? So what we're trying to find is what x equals, right? When this is set equal to 0. So I'm just going to fill these in, right? This is my A. This invisible 1 in front of it is my B. This is my C. And all we have to do is fill in the blanks, right? We have minus B. Well, that's just minus 1. Plus or minus the square root of B squared. Well, that's 1 squared. Minus 4 times A, which is 3, and C, which is negative 10. Starting to get better at this pen. All over 2 times A, and A is just 3, right? We should get 2 solutions, right? Because we have that plus and minus. So let's start with, we'd have minus 1 plus or minus. Let's look at our insides here. 1 squared is 1. This is going to be 12 times 10 is 120. Negative times a negative is a positive. So we're saying 1 plus 120, which is 121, which is convenient because that's a perfect square, over 6, which is minus 1 plus or minus. Does anyone know what the square root of 121 is? Just for a little. Yes, Avery, thank you. It's 11 divided by 6. Now, here's what I mean by there's 2 solutions, and you might remember this. I have minus 1 plus 11. Well, that's 10 over 6, right? Can't keep it that way, though, because those are both even. So this would be 5/3. But I also have minus 1 minus 11, which is negative 12, right? And negative 12 over 6 is just negative 2. So I have 2 solutions here for this problem, right? My 2 solutions are going to be x equals 5/3, and it equals negative 2. These are the zeros of my function. All it means when we're talking about zeros of a function is what happens when we set this equation equal to 0. What are our solutions when we set this equal to 0? What it also means, the reason we're talking about this in graphs, is these are our x-intercepts. It's where the graph of this line, or in this case parabola, is going to cross our x-axis. right? If I was to graph this, I would know that I have points at 5/3 and a point at -2. Does that make sense to you? I see a couple heads nodding. The ones that are actually on camera, I see nodding. We're going to do the other two problems too. I'm writing them down though, so that when I move to the next slide. Because my next slide is just a blank for us to show work. Right? I thought ahead. Our next problem was, I believe, I'm up a little high. G of x equals the square root of 10 minus x squared. We're going to start the same way. We're just going to make this set equal to 0. We're saying that when I'm going to write it this first, because for some reason I just like it better when what I'm solving for is on the left. I set that equal to 0. The first thing I have to do, I've got this under a square root. The way to get rid of that square root, though, would be to square both sides, right? Let's change colors so you can see I'm doing something different. So if I square this side and I square this side, I get whatever's underneath here, right? I get 10 minus x squared equals 0 squared is just 0. And then we can start solving for x, right? I'm going to subtract 10 from both sides, and I get minus x squared equals -10. I have this -1. All I have to do is divide everything by -1, and it goes away, right? If I divide this by -1 and I divide this by -1, I get x squared equals +10. But I don't care what x squared equals. I need to know what x equals, which means I have to take the square root of both sides, right? This will give me x, which is what I want to know, equals the square root of 10. I can't reduce that anymore. I can go, okay, well, it's 2 times 5, but 2 times 5 are both prime. I can't pull anything out of that square root. The one thing I need to remember, though, is when I'm dealing with square roots, it's plus or minus, right? Does anyone have any questions as to how I went about solving that one? And I hope that's a no. I'll give you a second just in case it's not. Now, this next problem you might think is ugly. I'm going to call it h of x equals 2t minus 3 over t plus 5, right? I am just going to set this whole thing. I'm going to get rid of this. Let me call this, get rid of that, and we'll just set it equal to 0. Right? I'm just changing my h of x equal to 0 because that's what we're trying to solve for. It should be h of t anyways because t is our variable. Does anyone remember how to clear a fraction? Would you know how to get rid of that t plus 5? Sarah, do you know how to get rid of it? Are you there, Sarah? See, when people don't answer me, I write their name down and then they become absent. Let's try Michaela. Do you know how to get rid of that t plus 5? How would you clear that fraction? Well, it's being divided by, so yeah, you would multiply. Exactly. What would you multiply though? Well, you would multiply the whole bottom, right? We would take this entire bit right here, and we would multiply it up here, t plus 5. Because remember, when you multiply something, when you divide something by itself, it just becomes 1. So just like when we're trying to clear a fraction and it's just a number, we're going to do the same thing. And we'd also multiply this side times t plus 5. I usually like to change colors when I do that. What this does is it cancels this fraction, right? And so we're going to be left with 2t minus 3 equals, well, 0 times t plus 5 is still just 0. So now all we have to do is actually solve for t, which I know you guys know how to do this, right? We're going to add 3 to both sides, and we get 2t equals 3. And then we're going to divide by 2, and we get t equals 3 halves. Sarah, did you come back yet? It's like one of my pet peeves is to just pretend to be here during class. The other thing we're going to talk about is we are going to look at the zeros of a function and how to see them on a graph, right? And these are the same problems that we just did. They're just graphed now, right? And we came up with the zeros already. You should be able to look at the graph of an equation and find the zeros, because they're all they are these points where we intersect the x-axis, right? They're just your intercepts, right? This is the graph of that first equation, that parabola that we made. This is the graph. Your zeros, I feel like I just made a face on there, are where we cross the x-axis. We came up with zeros of -2 and 5/3, right? And this is what they look like on the graph. Here, we had plus or minus the square root of 10, minus the square root of 10, plus the square root of 10. It's all we're talking about is where we're crossing these axes, right? Before I let you go, this will be our last thing, but I want all of you, and you should be doing this on a piece of paper, you should be taking notes while we do these lessons. I want you to find the zeros of this function right here. Then I want you to put your answers into the chat box, and do not hit send until I tell you. This is going to be your attendance. It's going to be your participation credit. I want you to find the zeros of this function. Clearly, you're going to have to do a quadratic formula on it, right? You're going to have 5 minutes. So you have until 8:45. And then I want you to put it in there and do not hit send until I tell you to hit send. There will be points for this. You will get participation points. So if you do not enter anything into the chat box, you will get a 0 for credit in class today. I'm not as concerned about you getting it right as I am about you participating. I'm going to stop the video because we don't need to be doing the video anymore.